Hello, and welcome to the Spatial Model tutorial number 9. The current video is about estimating the quality of time flow. It is about evaluating how well the spatial model predicts the flow time between two single locations in the network. Once you watch this video, you could estimate if the time flow is correct. You could also identify exceptional cases in which time flow cannot be predicted, but confidence intervals can. Confidence intervals for estimated measurement are good enough for alarms detection. You will even understand the different considerations of preferring sensors for determining time flow and how to use this preference in the model setup. Flow time measurement quality for each pair of stations is on the model edit screen. It can be reached by selecting a pair model and pressing the highlighted key. After displaying a model edit screen, select the rightmost tab that carries the title, Learn Chart. You can see the model's study results regarding the duration of flow between stations in the different flow regimes. First, you must select a flow regime from the field marked with the blue arrow. After selecting, press the orange highlighted key to display the updated graph. The horizontal axis indicates the possible delay times between stations. The values are in minutes. The axis ranges from 0 to 1440. This range means a possible delay between the instant transfer of water between the two stations and a possible suspension of 1 day. The vertical axis indicates the degree of adjustment for each delay time. A higher value means better latency time. The maximum vertical value in the displayed graph is 820. It means that for normal daytime flow, the duration between the two selected stations is 820 minutes. The picture may not always be as bright as the previous example. Sometimes the resulting graph includes several records, as in the example above. This example has 3 local maximum points, each of which could theoretically indicate a maximum match. In this case, sometimes, user judgment is required. If in the example before us, the user knows that both the right and left values are not reasonable, he can restrict the search domain of the model. For example, to search in the range of 400 minutes to 1000 minutes. In this case, the model will select the midpoint as the optimal point, and the station delay time will be approximately 680 minutes. The way to control the maximum point obtained is by using advanced parameters, which are in the tab that bears the title Advanced. As you can see in the image, this buffer contains 2 settings that take the title: min lag time and max lag time. In these fields, the values 400 low value and 1000 high value respectively must be placed. In this case, the point you select as a flow time is a middle point from the previous diagram. Another consideration that should guide the process of estimating the correct delay time is the sensor used for measurement. The illustration presented before us is of 2 different sensors, which apply to calibrate the time lag between the same 2 stations. The right part of the example refers to the estimation using turbidity. The left part estimates with the help of pH. You can see that the answers to both models are close. The right-hand model that estimates turbidity delay time reached an evaluation of the flow time of 1020 minutes, while the left-hand model using pH measurement arrived at a flow time of 855 minutes. But you can see that the left model is more decisive than the right. Its high point is much more evident. Experience has shown that measurements based on electrical properties of water, such as conductivity and pH, yield better results than models based on chemical properties such as dissolved chlorine or physical properties such as turbidity. In this case, a model whose estimation of delay time is not decisive may be required to use the estimate of delay time from a model based on a more decisive sensor between the 2 stations. The way to do this is explained in the next slide. The way to determine an after-source model of delay is shown in the diagram before us. The graph shows the edit buffer of the model variables. In this tab, a square appears bearing the title lag time source. This field lists all couples who calculate the delay time themselves. You can select the Use Other Pair data field and choose the source of the displayed list. In this case, the model will not calculate the delay time itself but will use the delay time of the selected model to serve as the source. Please note that in pairs used as a source of written activation are prominent, whereas models used in other models to calculate the change time appear in ordinary writing. One last point to remember is that it is not always possible to calculate the flow time between 2 points with the help of identifying changes. Sometimes when the variation between day and night or midweek and weekend records is not significant, calculating the flow time is difficult. In this case, you should extend the study time of the model. The area marked in the diagram shows the fields controlling the learning period. Keep in mind that enlarging the delay time learning window increases the learning time. Therefore, this parameter should be used with caution. We hope that this tutorial was helpful. If you have any comments, please update in our website.